today we're going over 7.4 notes, division properties of exponents. So understanding division properties of exponents allow you to simplify quotients involving exponents. So what is 6 to the 6th power divided by 6 to the 4th? We already learned about this, is just more of a review. So the first method is to evaluate 6 to the 6th power, and then 6 to the 4th power, and then divide. So if you do 6 to the 6th power, you're going to get 46,656. And if you do 6 to the 4th power, you're going to get 1,296. So if you end up dividing 46,656 divided by 1,296, you'll get 36. But there is an easier way that we've gone over. Method 2, I think there's 3 methods, but I'm going to go over the ones that are on the worksheet, and then I'll show you the third one. Method 2 is expand the numerator and denominator. So if you notice, we have now 6 sixes here. So 1, 2, 3, 4, 5, 6. And we have 4 sixes down here. 1, 2, 3, 4. And because there are the same amount, you can actually get rid of all of these 4 as long as you do it to the top. And you're left with just 2 6 on the top. So if you do at the end 6 times 6, you're going to get 36, which was originally what you got in the beginning. Now, when it comes to exponents, remember, if it's the same base, you can either add or subtract the exponents. When you're dividing, you're subtracting. Again, we've seen this before. This one just gets a little more in depth with variables. So we have 6 to the 6 divided by 6 to the 4. You're going to end up just subtracting 6 and 4 to get 6 to the 2. Or 6 squared, which is just 6 times 6, which is again 36. Which will make it a lot easier. That is the third method I was telling you. They just included in method 2. The division property of exponents also allows you to simplify quotients that contain variables. So as I was saying, you can solve for variables and or numbers as long as the base is the same. So key concept, you can subtract or add depending if it's multiplication or division as long as the base is the same. So if we have, for example, x to the 5th is over x to the 3rd, that's going to equal x to the 0 to a second as long as x is not 0. So x cannot be 0 because remember, in the denominator we cannot have a variable equaling to 0. So after dividing out the common factors, you're left with x times x, which is x to the 2nd. Notice we can cancel out the 3's here and 3 on the top, and we're left with just 2 x's, which is exactly what we have right here. So the division property of exponents works whether the base in the problem are constants or variables. And when you divide powers with the same base, again, right here, key, same base, you can subtract the exponents. In the example, we have x to the 5th and x to the 3rd are powers with the same base. And you divide them to get x to the 2nd. Now, just as an example, if we have x to the 3rd over x to the 5th, you're still going to subtract 3 minus 5. And that's going to give us x to the negative 2nd. Now, x to the negative 2nd is just going to be simplified to 1 over x squared. Remember, the negative doesn't mean the answer is wrong. It just means it's in the wrong place. We just put it at the bottom of the fraction, and it's fine. So for number 1, we're going to do 7. 5 minus 2, which is just 7 to the 3rd power. I'm going to leave them in exponential form. This one's going to be 3. 9 minus 2, so it's just 3 to the 7th power. Remember, for number 3, that 5 at the bottom has an exponent of 1. So we can just write it as 5, 2 minus 1, which is just 5 to the 1st power, which is just 5. For number 4, it's going to become 4, z minus 4. And that's all we can do because z is not a number. Here we have m, 3 over 4 minus 1 over 2. This is going to become 2 over 4. So our m is actually at the end. M is going to equal 1 over 4. For 6 is p, 6 minus 5, so it's p to the 1st power, so it's just p. For 7, the same thing happens as number 3. This is a 1, so it's going to be r. 3 minus 1, or r squared. Here is x, 5 minus 3, and then y, 4 minus 1. So it's going to end up being x to the second, y to the third. For number 9 is a, 3 minus 5. So that's going to be a to the negative second power, which again, because it's negative doesn't mean it's the wrong answer. It just means it's not in the right place. So it's going to become 1 over a squared. And then lastly, we have the 10 and the 15. We can simplify by 5. So it's going to become 2 over 3. And then x is going to be 5 minus 2. That's going to be 2 over 3. X, instead of 5 minus 2, it's going to be x to the third power. So this is your answer. This is your final answer. This is your final answer.